Hi everyone, welcome back to my YouTube channel TechDataEngineer. So in this video we will see frequently asked questions related to BigQuery. Okay, so if you are a data engineer and if you are appearing for any interview, so mainly if we are cloud focused also, right? Cloud native data engineer. So they mostly either you are aware with Azure, AWS or GCP. Okay, so this is basically for GCP data engineer who have the GCP as a cloud, primary cloud. So mostly they can ask the questions related to BigQuery, data proc, cloud composer, PubSub. So I'll create 10, top 10, 20, 30 questions related to each and every topic so that you can understand how to answer the questions. And this is not the they can ask some concepts also related to that. They can ask some counter questions also related to that. So I'll try to explain, I'll try to simplify the answers of this all these questions. Okay, so let us start with first BigQuery. Then if we'll complete the BigQuery, then we'll go with the data proc. Then we can go with PubSub, then Cloud Composer, and many more. We have the topics, so we can cover entire things related to that. Okay, so yeah, let's start with the first questions. Okay, so we will see what is first question. So first they can so the questions might arise, how does BigQuery store data? Okay, so we understand how basically. So if we have not if you don't have the idea about BigQuery, plus please go and watch my BigQuery series where I have explained the BigQuery architecture, storage, processings, compute layer also. Then like I have explained each and everything from GCP consoles and theoretical also. So please go and watch this. So here only I'm going to explain the questions related to that. Okay. So first question they can ask, how does BigQuery store data internally? Okay. So we know we have two types of storage, right? We have two types of storage. First is called columnar storage, column label. Okay, that is called columnar storage. Okay, and second is called row label storage. Okay, row label storage. Okay, so we have two types of storage. One is the columnar storage where column is getting stored, and one is the row level storage. Okay, so BigQuery basically store data in column format. I am not writing the theoretical questions here. Okay, so so we have BigQuery uses the columnar storage basically, that is called capacitor. Okay, so BigQuery uses a columnar storage format called capacitor. Okay, so unlike row-based storage, we have row-based. Suppose how I can explain the row-based storage here. So how row-based storage is getting stored. So if you see the row-based, uh, it's one Abhishek and Delhi. Okay, then we have the second Rahul and Mumbai. Okay, so this is basically row-based. Row-based means it's the serial number. Okay, then we have the name and we have the city. Okay, so data is getting stored row based. In column based, how BigQuery basically store? So if you see BigQuery, how it is getting stored? So first it is storing the ID. Okay, first it is storing the ID. ID is like 1 2. Then how it, what it is storing? It is storing the name. It is storing like Abhishek and Rahul. Then third, it is storing the city. Okay, cities Delhi and Mumbai. Okay, so this way column level it is data is getting stored basically in BigQuery. Okay, so apart from that, this architecture, so BigQuery uses a column level storage that is called capacitor. You can we can just explain the benefits also. So what they can, then the counter question they can ask, what is the benefit of storing column level? Okay, so we need to understand the benefits also. What is benefit? So in column label storage, we only read only required columns. Okay, so only suppose we require name, we can go, we can take the name things only. So read only the required columns. Then we have the second point, we have the excellent compression. Okay, excellent compression. Okay, then what is the third things we have? We have the faster aggregation. Okay, faster aggregation. Then we have less input output. Okay, then we have less input output. If less input output, then we have the lower cost also. Okay, lower cost. Okay, so this way only we can, so this way basically we are storing the data in BigQuery. Okay, now this we can understand, the BigQuery execution architecture. Okay, so we have already understand the first question, so how BigQuery basically store the data. Now we will see the how BigQuery execution architecture. What is the like explain the BigQuery execution architecture. Okay, so we will see that things also. Okay, so in BigQuery basically what happened? So when query start, right? So how there is a user. Okay, so there is a, suppose there is a user. Okay, so there is a user asking the query, then we have the SQL parser. Okay, then what we have? We have the query optimizer. We have the query optimizer. Then we have execution plan. Okay, execution plan. Then we have the workers, distributed workers. Okay, distributed workers. Then we have the shuffle. Okay, and then we have the aggregations and result. Okay, then we have aggregation and result. Okay, so these are the steps we have. So now I'll explain what basically these all terms we have. Okay, 1 minute. Okay, so we understand, right? So BigQuery is basically a serverless and so basically BigQuery is basically distributed and serverless. What distributed means? It's like a parallel processing they have. So whenever the user is asking the query, it goes to SQL parsers, then we have the query optimizer, then we have the execution plan. Query optimizer means validator, then plan, then we have the different distributed execution plan, then short allocations, and then all these things happen. Okay, so so we have two things. One is the front end basically where we our SQL parsers are there, authentication, authorizations, metadata management, all are there. Then we have the query optimizer is basically like predicate push down, join reordering, partition purnings, cluster purning. Then we have the cost based. Then we have the distributed engine, basically slot scheduler or worker allocations. So this layer. Okay, and then what when we have the capacitor storage, basically parallel process, it will run the columnar processing as will store the data. So whenever like whenever we are writing the query like select star from table. Okay, so what it will this query is sent to BigQuery. Okay, so nothing execute immediately. First what will happen? SQL parsing happen, like syntax missing, command validation happen. So we need to understand, we need to tell these steps. Okay, so they will ask questions related to how BigQuery execution architecture, so we need to tell the steps. Okay, it is not like whenever we are writing the query, it automatically it is giving the result. Okay, so we have to understand each and every stages. Okay, now we will see the third questions. Okay, okay, we will see the third questions related to that. So third question is, what is slot? Okay, so in BigQuery, what is slot? So slot is nothing but it is basically a unit of computations. Okay, so we can say that slot is nothing but it is basically a unit of computation. Okay, what do you mean by one unit of computation? So one slot is basically equals to, we can consider one slot equals to one CPU plus memory plus network. Okay, we can consider like that. Okay, so BigQuery allocates slot automatically. So how BigQuery allocates slot? It automatically allocate the slot. So suppose we have the 100 workers. Okay, suppose we have the 100 workers. 100 workers means 100 slot. Okay, so more slot means if we have more slot, so they can ask questions, counter questions. So what is the benefit of more slot? So more slot means more parallelism. Okay, more parallelism or faster execution. More parallelism, and we have the faster execution. Okay, these things happen. Okay, so we understand what is slot. Now we understand difference between on-demand pricing and reservation. Okay, sorry. So what is difference between on-demand and reservation? Okay, so we have heard this question. So this all are the scenario based. So on demand and reservation. Okay, so on demand there are two concepts: on demand and reservation. Okay, so on demand is nothing but, so you only have to pay how much data getting scanned. Okay, so pay per TB scan. Okay, pay per TB scanned. Okay, so if I am writing a query and suppose my data is getting scanned is suppose 50 GB. Okay, so I have to pay only for the 50 GB. Okay, in case of BigQuery. Okay, so that is basically pay per TB scan. So which types of company they are using on demand? So basically we have small companies or ad hoc based companies, small companies or which they are using the ad hoc related things. Okay, ad hoc queries basically. So ad hoc queries are useful for on demand services. And reservations is basically we buy the dedicated slot. We can buy the dedicated dedicated slot. So we understand what do you mean by slot. So this is ideal for big company, and we understand we have the predictable workload. Okay, we understand that our workload is needed this much of resources. So if we have the predictable, we have the if we know we have the predictable workload. Okay, predictable workload. So these types of company basically using the reservation. Okay, now they can ask questions, explain the query stage. Okay, so what is query stage? Okay, so suppose I'm reading the data. Okay, so first is the read data. Then what is the next step? We have the, if we have any filter condition, filter. Then we have shuffle. Okay, if shuffle operation is there, shuffle we can do. Then we can do the join. Then we can do the aggregation. Okay, then what we can do? We can give the output. Okay, we can give the output. So execution details. So how much slot uses? So if we are executing the any query, so what it basically, so it basically slow the slot uses. Slot uses basically the resource uses. Then what is the shuffle size? Okay, shuffle size. Then what, we have the CPU, we have the memory. Okay, useful for computations. Okay, now we will see the next question, difference between partitioning and clustering. Okay, so what is partitioning, what is clustering? Okay, so partitioning is something, we have the huge data. Okay, we have the huge table, and table is getting and data is getting stored date wise. Okay, date wise, so date wise we have the 10 years of data. Okay, 10 years of data. Okay, and the data is not organized in not partitioned. Okay, so what we can do, we can store the data year wise. Okay, what is the benefit of storing the data year wise? So if we will store the data, and suppose tomorrow someone is performing the query on that, and if the data is from the 2025, 2026, 2024, something like that. Okay, we have this slot, we have partitions. So that data, that query need to scan data from that particular year. Okay, so any table, so partitioning is what, so data should be, partitions are stored based on some column. Okay, so if I'm doing partitions partitions by year. Okay, so partitions by year if I'll do, so data is getting stored in the partitions manner. Okay, so 2025 data is stored in this one partition, 2026, 2024, 2023. So that is basically partition. So only partition, and whenever we are performing any query, only that partition is getting scanned. Okay, so what do you mean by clustering then? So cluster is within the partition. So first we have to define the partitions. So in 2025 partitions, if we are storing the data based on certain country, okay. So first it will give the data for X country, then Y country, then Z country. Okay. So based on this year, if you wanted the data, clustering of the data, so first suppose, so same year of data, so same year, same country data it will give first, then later the other country, then similar to that. So year wise, and then we have the customer A. Okay, or country A. First we will give country A, then we have the country A, then we have the country B, country C, and this belongs to the single partition, that is year wise 2025. Okay, so first we have to define the partitions, and then we have to define the clustering. Okay, so clustering basically it stored the data physically. Okay, clustering basically stored physically. So what is the use of that, so what is the benefit of that? So because of partitioning and clustering, we are reducing data scan. Okay, this is one of the benefit we have. Okay, so partitioning is used for data, for the partitions for data, and cluster for filtering the column. Okay, now then they can ask the questions, so which types of partitions are based? Okay, so there are three types of partitions. One is the ingested time based partitions. Okay, ingested time based partitions. Other is date wise, date column, any date column. Okay, any date column. And third is the integer range, if we have the integer range data. Okay, integer range. Okay, so these three types of partitions we have, we can explain these things also. Okay, now coming to the next questions, what do you mean by materialized view and view? Okay, so we will see the next questions. So this is nothing but, so first we have the table. Okay, we have the table, that is physical table, and then we are creating two types of view. One is the materialized view, and other is the view simply. So from this table we are taking the either sub columns or full column, and then we are creating the view. Okay, so our normal view is running every time. Materialized view is nothing but it is basically a pre-computed result. Okay, so if this is basically a pre-computed result, every time the data is we don't have to scan the data, so the result is computed. Okay, so this is automatically refreshed, much faster. That's why we are using the materialized view. Okay, so daily sales data, suppose we are basically using the materialized view. Okay, so view and materialized view I've already explained also, we can see that video. Now, what is time travel? Okay, so this is also very important. So suppose we have data of today, tomorrow, yesterday. So data yesterday, day before yesterday. So BigQuery. So BigQuery keeps BigQuery keeps previous version. Okay, BigQuery keeps previous version for each computed result. So suppose I am writing like select a star from table for system system as okay as of sometimes time I'm giving. Okay, so basically we are keeping the previous version of each data. So why basically time table is required? So time table is basically required to recover the deleted data. Okay, recover deleted data. Okay, so timetable is basically required for recovering the recovery of deleting data. So default, what is the default retention policy? They can ask the retail default retention policy is 7 days in case of BigQuery. Okay, and that can be extended with a table snapshot or backup depending upon your setup. Okay, so how you are setuping. So you can just create a snapshot also, and then you can set the time based on your requirement. So that's why we are using the time travel. Okay, then next question is the what is query optimization technique. So all of these questions I have already explained what we can do in query optimization. What we can do, we can use the partitions. Okay, we can use partitions, we can use cluster, then avoid select a star. Okay, avoid select a star. Okay, then what we can do, we can filter early. Okay, we can filter early. Okay, then what we can do, use approximate function. Okay, approximate function, then you can use the materialized view. Okay, these are the query optimization techniques. Okay, then reduce the shuffle. Then what we can do, we can reduce the shuffle operation, how much it is possible. Then optimize the merge statement. Okay, optimize merge merge statement. Okay, then we can check the execution details. Okay, check execution details. So these are the things we can do, and this way we can basically optimize our BigQuery. Okay, so these are the query optimization techniques. Now next question we'll see, how do you debug your slow query? Okay, so they can ask is how do you debug your BigQuery? Okay, so debug your basically slow query. So how we can debug your slow query? What we have to do, first go to the BigQuery console, then check check byte scanned. Okay, first is the things we have to do, byte scan. Then what we have to do, review the execution graph. Okay, then what we have to do, we can review execution graph and stage. Okay, so based on that also we can check the query slowness. Okay, then identify the large shuffle operation. Okay, identify large shuffle operation. Then what we can do, check whether partitions cluster purning occurred or not. Okay, so check whether partitions or cluster punings are there or not. Okay, okay, then what we can do, we can look for data skewness. Then what we have to do, we can do next, we can look for data skewness. Okay, data skewness. Then we can verify the join operation. We can verify join operation. Then what we can do, we can rewrite the query if needed. Okay, rewrite query. Okay, so these are the steps which we can follow and we can check the slowness. Okay, they can ask questions related to how do you reduce big query scan. Same things we can perform. How is one query much slower than others? Okay, so these all things we can do. So sometimes they can ask questions related to how your scan 10 TB but return the only 100 or something like that. So these types of scenario based question they can ask. Okay, so I try to cover each and everything in from BigQuery what mostly they can ask. So if we have any questions or any unanswered concepts, please do below comment so that I can answer that questions also. Okay, next upcoming video. Okay, thank you. Thanks for watching.